Video 40. Non-homogeneous linear recurrence relations. A non-homogeneous linear recurrence relation is of the form non-homogeneous recurrence relation with constant coefficients. Is of the form C naught an plus C1 a suffix n minus 1 plus etc. plus Cn into a naught is equal to f of n, a function of n, Cn into, where C naught, C1, etc., Cn are all constants. Its solution is given by non-homogeneous. Its solution is given by a suffix n is equal to a suffix n of h. That is solution obtained from the homogeneous part. Homogeneous part means by taking this right hand side 0, if we solve for an, that is the solution of the homogeneous part. Then after considering f1 on the right side, this particular solution. So H for homogeneous, P for particular solution. Trial solutions to find the particular solutions are given by in the following table. So this is form of f of n. Here trial functions. So first one, b power n, f of n is equal to b power n, where b is not a root of the auxiliary equation or characteristic equation, is a root of the characteristic equation. In this case, our f of n trial function must be a into constant times b power n, and we have to determine what is the value of e. Second one, b power n, where b is a root of the characteristic equation of multiplicity. B is a root of the characteristic equation with multiplicity t. Multiplicity is t. In this case, we have to consider a into n power t into b power n. Here it is not a root of the characteristic equation. This is a root with multiplicity t. So this is one form. Then next we have f of n is a polynomial. Third one, f of n is equal to a polynomial of degree m in n. So in this case what we'll have to do is, our function is a0 plus a1n a2n squared plus etc. an power m, polynomial of degree m is a polynomial of degree. Fourth one, if some c power n into f of n, that is equal to this polynomial. F of n is nothing but a polynomial of degree m, where c is not a root of the, where c is not a root of the characteristic equation, not a root of the characteristic equation. In this case we write c is a root of the characteristic equation, so that c power n into a0 plus a1n plus etc. This is am n power m. Close the bracket. Now the natural question is cn into f of n, where c is a root of multiplicity t for the characteristic equation, root for the characteristic equation. So just like we are multiplying by n power t, here also we have to multiply by n power t, multiplicity t, followed by c power n into a0 plus a1n plus etc. am n power m. So we have to determine the values of these constants a0 to am. So these are the different. Right hand side you can get in a non-homogeneous linear recurrence relation. So with these things we can solve some problems on non-homogeneous linear recurrence relations.